Live. Okay, we're live. Hey, Christine.
Hi,
How are you?
good.
Good. All right, almost all here. I wonder how many times does it ring for y'all when it calls?
I
That
just
time
get like
I did.
a up on the phone.
It goes ding 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 on my phone. On my cell it does that, but I don't know.
Yeah, that's what it does for me.
Okay. I'm wondering if it only does it like once or twice and then it stops. If I should like resend Levi another one. Let's see.
Yeah, because I think you can miss the call.
Yeah, you can if you don't get. No, that's not him.
I hope that Levi knows that we meet every Tuesday and Thursday at this time.
That's right. I texted him last. Let me see if I can find him. I didn't put his name. Let me see if I can find this text or a text. It was like, hang on. Do you have any idea what his number started with again? Did I write
uh,
his phone down?
I think it was an 801 number.
You know what? That's right. He was Utah. Okay, let me see. Let me start over. Ironically, I have a lot of numbers. It's just numbers. It's not people because of my work. I don't bother adding them. Okay, here he is, 801. Let me text him. Okay. All right. Okay. I told him I would send him another invite. We'll let him get that one. And then I'm sending him one now. There.
I don't have like a ton of time today either because my wife just got into hair school and we have to go fill out some paperwork. But I'll stay as long as I can.
That's cool. What school did she get to?
It's here in Rexburg. It's called Evans.
Oh, okay. Well, that's cool. All right. Well, it should be. I guess we'll go ahead and start. You want to start?
Yeah.
Okay. All right. We have our quiz up. We ready to go? Or whatever this is. Our group meeting.
I've got the quiz up.
Okay. 1 and 2 are true.
Are you sure?
I'm pretty sure. I'm not 100%, but I take my chances. Kind of wild like that. Okay. Number 3.
Number 3.
Does everybody have it up, or do we need to read it for someone?
I have it up.
There we go.
I have it up too. I haven't
I
worked
got
on it yet,
mine
so
up just
I'm
now.
reading.
So do we want to read it then? Like read through it, just go through the whole thing real quick?
Sure.
All right. When taking samples of of n when n equals 5, what was the shape of the distribution of means histogram when the parent population is right skewed?
I wasn't sure the answer on this. What did you guys get?
I popped up that little window thing that we played with that did
Right.
histograms. I ran it through, and it looks about normal, but there's a slight right skew on it. Like it's
That's what
right.
that's what I got too. So I was thinking skewed right.
That's what I put. And I think because when n is 5, I want to say that it would be, that's a small sample, isn't it?
Yep.
So it would be a
Yeah.
little right skewed, I think.
Yep.
I think so too, because what we've been learning is that the large numbers make it more normal,
Yeah.
so the small number would skew it as well.
If
Yeah.
it's already normal, then it would stay normal, but because it's already skewed right, and there's not a very big population, it should stay skewed right.
Okay.
Okay. So we all agree.
Skewed
Skewed right.
Yeah, okay. All right, number 4. When taking samples of n equals 100, what was the shape of the distribution of means histogram when the parent population is skewed right?
So I thought that's normal because you now have 100.
That's what I put.
I would just put normal.
All right, yeah, because 100 was pretty big, so it kind of started to even out.
Mm-hmm.
Where'd Ty go? Is he gone? Do y'all see him?
I don't see his picture anymore.
Maybe I should send him another invite?
Well, you can rejoin.
Oh, here he is. Okay, so you can find it and rejoin back into it. Join this group again.
I usually can. Like, when the first time you called me, I missed the call. And so, or it said the call timed out, and so I had to go back in.
I see 2 of you, Ty. Are you good, or do you have feedback?
No, I've got you now. I don't know why it just dropped me, like kicked me out.
Weird.
Anyway, so on number 4,
Yeah.
we got normal because the population's bigger. It's a larger sample size. Even if the parent population is like right skewed, the law of large numbers should apply.
I agree. I agree with that.
Right.
Okay, so we good. So number 5. When taking samples n equals 100, what was the shape of the distribution of means histogram when the parent population is normally distributed?
Still normal.
Yeah, normal.
Yeah, because it just said when the parent population is normal, then it
Right.
will
Yeah.
always be normal.
It doesn't matter how many of the samples you got, it'll still be normal.
Cool. All right. 6. When would the distribution of means be normally distributed? Choose all correct responses.
I did the 2 that said the sample size is large. What did you guys get?
That's what I was just looking at.
I did those. I also checked, and this may be wrong, but I also checked data are drawn from a population that is normally distributed and the sample size is small. I checked that one because it said it was already normally distributed, so it would be normal. Is that correct?
That's what I got.
It sounds
That makes sense.
right.
So we would click 3 of them, and the only one we wouldn't do was when it was right skewed and small.
Right.
Yeah, that's what I did. Does that
Okay.
sound about
No,
right? Or
according
anybody
to
else?
these 2 rules that they gave us, that's right.
That's what you got
Okay.
too. Okay.
Yeah.
All right. 7. Which of the following gives the best explanation of the central limit theorem? Yeah.
I clicked if the sample size is large, the shape of the sampling distribution of the sample mean will be approximately normal.
That's what I put.
That sounds like it makes sense.
Yeah.
Samples.
All right. And it was because that word that they put it in as normal, approximately normal, so that kind of gave it away.
Yeah.
And it says like approximately, which is kind of almost word for word they said in the book.
I have trouble hearing you, Ty.
Can you hear me now?
I can hear you,
Yeah,
but
it's
it's
just
really loud. Can you turn up your volume? Or does that not bother with us? I hear everybody else though.
Well, my volume's like all the way up. So.
Just talk closer to your mic, maybe.
There we go. How's that?
That sounds
Better?
better.
All right.
Good. Okay.
I was like, are you trying not to wake someone? No. That makes sense here. My husband works nights. I do days, so that would make sense for me. But okay. All right. So are we good on that then? The number
Yeah, I
7?
think we're on
Yeah.
8 now.
Okay. 8. Let x be a random variable with a population mean equals 10 and a population standard deviation of 6. Suppose a sample size you're in equals 36 is drawn from this population.
Should be 1.
What is the mean of the distribution of samples?
It should be 1.
It's 10 because it's the same as the population mean.
That's what I thought. I put 10.
Because they've had that on the other homework too. They keep trying to trick you, but the mean always stays the same.
And we don't really use it, do we, at this point? I mean, this is the mean.
Yeah, no, we don't.
I guess we'll use it next lesson. I haven't looked at it, but
Yeah.
So the mean always stays the same.
yeah, I have
Yep.
The
right
sample,
regardless.
the sample is always the same as the population mean.
Yeah.
there.
Okay.
It's the
So far.
standard deviation that changes.
Yes.
That's why. Okay.
The
All right.
standard deviation has a different formula. And on the next one, 9, that's where I got 1.
Yeah.
I got 1 too, but why did it say 3 decimal places?
They're trying to
it'd
trick
be-
you.
Okay.
It'd be 1.00.
I was just gonna say 1.000.
That, or else will we get kind of wrong if we don't put like a point
I
000?
don't know.
I don't
know.
think so.
No, you don't think so? Okay.
Well, it's a whole. I doubt it.
All right. I guess if it counts it wrong, we'll just we'll all email him to
Yeah.
go back and check it. I guess. All right. So 9 is 1. And 10, regardless of the distribution of the population, if the sample size is large, greater than 30, what would be the shape distribution of the sample mean? Oh, don't put it.
Approximately
normal.
normal.
Okay. Because it's so large, and they said that for our intents and purposes, we should
Yeah.
count 30 as large.
Right.
All right. What theorem would justify your answer in question 10?
Law of large numbers.
No, the central limit theorem.
Why is that?
The law of large numbers says that the larger the number, the smaller the standard deviation. But the central
That's right.
limit theorem says the larger the number, the closer to normal.
Oh, okay.
Yeah.
That makes sense.
That's what I put. I put the central limit theorem. But I did have to go back and read them again.
So, but there.
Okay.
All right. So that is 11 out of 11. Shall we hit
Okay.
that?
Yep, I just submitted mine, got them all right. So
I didn't skip anything because I tend to do that.
we didn't have to do .0000. So that's good.
All right. Very good.
What the heck?
Great.
Okay. Did
Yay.
anyone have any questions on anything, or you guys all understood?
We're
This sounds
good.
good.
Okay,
Yep.
great.
All right.
See you guys on Thursday.
Have a great
Sounds good.
weekend.
See you guys.
Bye.
Oh, wait. It's
Adios.
Tuesday. Okay. See you Thursday.